Bismillahirrahmanirrahim. My name is Rehan Ahmad. My roll number is 4. I am a student of BS Physics. Today my topic of presentation is classes of chemistry, definitions. A hard, brittle substance, typically transparent or translucent, made by fusing sand with soda and lime and cooling rapidly. It is used to make windows, drinking containers, and other articles. It possesses an indefinite formula or crystalline structure. Generally, a glass is made up of lime, soda, and sand. In our home, there are different types of glass: window, mobile screen, computer screen, a set of glass, or a set of tea cups, straws. It has a definite formula or crystalline structure. An organic product of fusion which has cooled to a rigid without crystalline, does not have a specific melting point, soften after a range temperature. Next, properties of glass. Glass is amorphous, brighter, transparent or translucent, good electric insulator, and unaffected by air, water, acid, or chemical reagent except HF. Non-definite crystalline structure means glass has high compressive strength, can absorb, transmit, and reflect light. Raw material used in glass manufacturing. In glass manufacturing process, the transparent or translucent, the transparent hard body is created by the application of vast amount of heat to sand or quarters. Glass is an amorphous, inorganic, homogeneous, transparent or translucent material which can be molded into any shape because based on the type of glasses its raw materials are collected and different compositions are sent to the manufacturing process. Following are the raw material for the different type of glass. Type of glass: soda, lime glass, chalk, soda ash, Na2CO3 and clean fresh sand, potassium, lime glass, chalk potassium carbonate K2CO3 and clean fresh sand, potash, lead glass, litharge, lead monoxide PbO3 and lead sesquioxide Pb3O4, potassium carbonate K2CO3 or pure. Common glass. Common glass is generally made by the raw material for a common glass is chalk, salt cake, Na2, SO4, coke or ordinary sand. Flow chart. This is a flow chart in which glass is made. Next, composition of glass. Glass is a crystalline amorphous solid that is often transparent and has widespread practical, technological, and decorative use in, for example, windows panes, tableware, and optoelectronics. Firstly, the glass was manufactured in Egypt. Ordinary glass is manufactured by the composition of various substances like silica, bleaching powder, oxide of alkane metals, calcium oxide, etc. These constituent of glass are transferred into more micropowder and other after fusing these are melted into the furnace at moderate temperature and ordinary glass is prepared by the suitable cooling mechanism of the molten of liquid glass. So, ordinary glass is a non-crystalline substance of ultra-cooled liquid glasses. Here, types of glasses. Firstly, flat glasses produced by the float process is often processed to suit many different applications and requirements with the vast array of technology in the glass industry. This guide will help you understand the four main types used in today industries. The float process was invented by Sir Alistair Pilkington in 1952, allowing larger and more constituent panels of glass to be manufactured than ever before. After 64 years, there are now 20 to 60 float plants worldwide which produce glass panels up to 3 meters in wide and between 0.4 millimeter and 25 mm thick. These plants, which can be up 1 kilometer long, produce a combined output of about 8 lakh tons of glass a week. Next, first type of glass, annealed glass. Annealed glass is a basically product formed from the annealing stage of the float process. The molten glass is allowed to cool slowly in a controlled way until it reaches room temperature, revealing any internal stresses in the glass. Without this controlled slow cooling, glass could crack with relatively like little change in temperature or slight mechanical shock. Annealing glass is used as a base product to form more advanced type of glass. Next, second type, heat strength glass. Heat strength glass is semi-temperate or semi-tough glasses. The heat strength process involves heat annealing glass back up to about 650 to 100 700 degrees Celsius and then cooling it quickly, although not as very fast as with toughened glass. The heat strength process increases the mechanical and thermal strength of the annealed glass, making it twice as tough as annealed glass. When it breaks up, fragments are similar in size to annealed glass, but with the greater look likelihood of staying together. This glass is often used in plastered Cluster trades are similarly structured applications because its limits are compared to tempered or toughened glass, although it is sometimes specified when there is concern about temperature. Tempered glass fracturing into thousands of small pieces. Tempered or toughened glass, third type of. It is the most common type of glass used in luster trades or similar structure application. Annealed glass is heated to about 700 degrees Celsius by conduction, convection, and radiation. The cooling process is accelerated by a uniform and simultaneously blast. Third one is tempered or toughened glass. It is the most common type of glass used in bluster trades or similar structured application. Annealed glass contains heated about 700 degrees Celsius by conduction, convection, and radiation. This cooling process is accelerated by a uniform and simultaneous blast of air on a board surface. The different cooling rates between the surface and the inside of the glass produce different physical properties, resulting in compressive stresses in the surface balanced by a tensile stress in the body of glass. These processes make the glass 4 to 5 times stronger than and safer than annealed or unthreaded glass. The counter, counter counteracting surface or surface comparison gives toughened glass its increased mechanical resistance to breakage. And what is when it breaks down, does break, cause it is produced small, regularly typically square fragment rather than long, dangerous shade that are far more likely to lead to injurious laminated glass. Any one of the above types of glass can be laminated. The most commonly used of finishing product into two sheets of toughened glass, laminated together with a 1.5 to a millimeter thick polyvinyl butyl interlayer. Laminated glass offers many advantages. Safety and security are the best known of these. So rather than shattering on impact, laminated glass is held together by the interlayer. This reduces the safety other association with shattered glass fragment as well as to some degree the security risks associated with easy penetration. If a glass panel breaks or shatters, it is highly unlikely then that both laminated panels will break at the same time. This means that the remaining panels and interlayer will support the broken glass and keep it in place as edge protection until it is placed or security suitably. Another increasingly common interlayer is the SGP interlayer. This product offers 5 times the tear strength and 100 times the rigidity of strength PVB. It is unlikely event of both pans of toughened glass breaking than the SGP will in most applications hold the glass in place. So SAGP offers an enhanced impact performance and greater protection against severe weather. A variety of other interlayers are available which apply a range of other technologies to the application. Structural interlayer can be used to enhance the strength of the glass which high loadings are required. Colored interlayer can be used for privacy or purely decorative purpose. Other properties such as sound, damp, damping, and fire resistance can also be incorporated into the interlayer. How glasses get colored. During the preparation of glasses, its various components are constituted in the molten or fused states or sometimes altered or replaced more appropriately. Some extraneous substances like metallic oxides are accessed or added. The glass become colored. Also, various accessible substance produce different colors in the glass. For example, on assessing ferric oxide in ordinary fused glass, a brown color glass produce. Similarly, some substances like chromic oxide, magnesium oxide, cobalt oxide, etc. are mixing in fused glass. Green, red, and blue colored greens are produced. Next, substance used for the color of glasses coloring the glass. Cobalt oxide have a deep blue. When we entered sodium chromate or ferrous oxide in a furnace, its colors it gives the color of green. Selenium oxide, orange, red, ferric sulfide or sodium orient gives the color of fluorescent yellow. Gold chloride or purple of glaciers, ruby red, syrup oxide, sodium sulfide, glitter red. Syrup oxide, peacock blue, potassium dichromate gives the green and green yellow. Magnesium oxide can also give the blue or light orange. Syrup salts red. Sodium sulfide yellow like lemon. Carbon brownish black. Step step process for the glass made. The art of manufacturing glass is an old one. It was a process which has been refined for thousands of the years. With technology become increasingly advanced, glass manufacturing has begun producing float glass, which is certified, durable, and compatible with glass processing procedures of lamination, temperature, aciding, etching, sandblasting, etc. Firstly, here melting and refining. Second, float bath. Third one is coating and reflecting, and fourth one is annealing. Thank you. The end.